Alright, this is Ken Rosever, and a little while ago I made a video about finding the population standard deviation, and I explained it using this formula. And in Alex I did the calculations, but I thought it would be beneficial if I did it by hand. And then I just found this cool formula which I wasn't aware of, which I didn't see in the book, but which is another way of calculating this and is easier for small numbers. So when we're finding the standard deviation, which is sigma, we're taking the square root of the square of the differences divided by n, or the average of the squares of the distances. So we're taking the square root of the average of the square root of the average of the squares of the distances. Okay, but just remember the formula. So the first step was always to find the mean, and I did this a little bit ago. I think the mean was 54. Let's just call this 10, 20, 30, 40, 50, 60, 60, 58, 55, 54. Yeah, it is. Okay, never mind how I did that. Okay, so this is 9. Well, then once you have the mean, you're going to do the difference between each of these numbers and the mean. So the difference between 10 and 9, 10 minus 9 is 1, 1, 0, negative 2, 1, and 1. Nope, negative 1. And when you add these up, 1 plus negative 2 plus 1 plus 1 is 0. So we're good. Those are the differences. Now we need to do the sum of the squares of those differences. So let's do 1 plus 0 plus 4 plus 1 plus 1, because I'm squaring all these over here. Well, that comes out to 8. And that is what my numerator is here. 8, which I'm dividing by 6, and I'm going to square root that. So it's going to be the square root of 4 over 3. And you can like write that as 2 over the square root of 3. And then you can do this, and you can get 2 square roots of 3 over 3. But who cares? This is good for what I want to do. And besides, in Alex, this isn't trigonometry. You're not going to leave it as an irrational number. You're going to write it as a decimal. So this is fine. Now, as I was looking, I found something cool. So let me show you it, and I'll bring it up. This is an alternative way of calculating it. Why did you not come with it? Alright. It is the square root of the sum of the x squareds divided by n minus mu squared. So little different. We're going to do the sum of the x squareds, not the sum of the squares of the differences. Okay, but the sum of the x squared. So this is very easy in Alex. I'll show you on the next problem how easy it is, because this problem is no longer up there. But it's not that hard by hand either. So if we have 10, 10, 9, 7, 10, and 8, then the sum of the squareds would be, first we square them, and then we add them. So what do I see here? I see 300. So it's going to be bigger than 300. Let's just do this. These two make 130. With this makes 194. So it's 494 is the sum of the squareds. So I'm going to do 494 divided by 6 minus 8 squared, right? No, sorry, mu squared, 9 squared, which is 81. So, and I'm saying that this formula, sorry, I should use a highlighter, this formula here is exactly the same result as this one. And I'm going to show you that by example, not by converting this formula via algebra to this one, but just show you that this quantity here Though it looks different from 4/3, it actually is equal to 4/3. How are we going to prove that? Well, I'm going to go 494 divided by 6 is the same as 247 over 3, correct? If I divide the top and bottom by 2. Now this is 81, so if I want to convert 81 into thirds, I multiply by 3 over 3, so I get 243 over 3. There's a minus sign in the middle. And when I have a common denominator, now I can just subtract the numerators. 247 minus 243 is 4 over 3. So you can see these match. So there you go. This formula is a valid way of calculating just as much as this one is. Now it depends on you which one you want to use. This one is quicker if you're using Alex. The second one is quicker. Okay. If you're doing it by hand, it's really up to you. We're going to do another problem with Alex just so you can see it. Here we go. So what is this? This is another population standard deviation. See, I'm learning new stuff as I do these for you. So what are we trying to calculate? We're trying to calculate, well, first let me get the divide by 6. There's my average. It's 44. I'm going to store that. Okay. Next thing I need the sum of the squares. So let's go sum of the squares. Wow, that's a big number. But I'm going to square root it. I'm going to divide it by the population. I'm going to arrow over. Minus. Recall that number, which was the mean, squared. And I hit enter. And it comes out to that. That just seems huge. That doesn't make sense, right? How can that be the standard deviation? Let's try again. I'm going to do this, sum of the squareds, okay? And then I'm going to put that under square root, divided by 6, arrow over, minus, recall, squared. There we go. That's better. Always look at your answers with a critical eye, because if they just seem wacky, it could be that they are. So there's my answer, 7.30, rounding to 2 decimal places, and very good. Okay. Do I have time for one more shot? Yeah, we'll do one more. So let's hit done. And I'll hit review again. We'll do one more. We want to first find the average. Easiest way to do that is drag across the numbers, hit sum of the x's, and this time there's 5. So we divide by 5, we'll get 20. Okay, and you can remember 20. There's no need to store it. Next part, we want the sum of the x squareds. Not easy to do by hand, but very easy in Alex. Drag and hit sum of x squareds. Now we're going to square root that quantity, dividing it by 5, and arrow over. The reason I arrow over is because if I don't, the minus ends up down there, and I don't want it there. So I arrow to the right, and then I hit minus. Our average was 20, and 20 squared is 400, so you could just write 400 or hit the squared button, enter. And it's saying it's 8.877, so 8.88. We're going to round up to the next decimal here because after the 7 comes a 6, so it's greater than 5. We round the 7 up to 8. That's it. And we are good. We've mastered it. Well done. Okay, that's it for this video.